Hello, welcome to Functional Bar. My name is Charles, and in this video, we'll be discussing variables. First, we're going to talk about different ways to think about variables. If you don't know what a variable is, that's fine. We're going to talk about it. Then we're going to talk about how they're immutable, and something special for Haskell functional languages and why we keep them immutable. We're going to talk about how to actually make the variables in Haskell. Then we're going to talk about how to glue our strings together, and then finish up with some suggestions for practice so we can get used to the new things we've learned. So let's start with how different ways to think about variables. What is a variable? I find the easiest way to think about a variable is as a box that I put things in, and then when I need them again, I can take them out of the box. And that's a container. And in programming, we use containers a lot. We have lots of different kinds of containers. A variable is one kind of container, and that's an idea that gets reused over and over because it's so very useful. Another way to think about variables is that they're names. They're like names. We give an expression a name. We give a value a name. This is probably the most accurate way to think about it in Haskell, at least. In other languages, the container, the box might be the most accurate way to think about it. But it doesn't matter what language you're in, you can always think about variables as containers or as names for something. That always is going to work everywhere. This last thing is variables bind a name to an expression. I'm putting this in. This is rarely used. The people who use it often have very good reason to. Sometimes it's just personal preference, and that's 100% okay. Other times it's to emphasize the fact that the thing we're binding has some special properties. But if you hear I'm going to bind it to something, that's the same thing as I'm giving it a name. That's all that means. I'm giving something a name, especially in context where variables are being discussed. Now, variables in Haskell are immutable. If you don't know anything about programming, that's fine. You can ignore it. We're never going to, immutable just means we can't change them. They're not changeable. So immutable, we can't mutate them. In other languages, so if you're coming from a different language or have some programming background, you think, oh, I can change these. I ought to be able to change them. It's very common in procedural programming, or at least used to be. It's becoming less common now because when we change a variable, when we can change the contents of a variable, that's how we get bugs. That introduces bugs a lot of the time. Often they're hard to find and hard to fix. So it's better just never to do it. And in fact, JavaScript is fairly recently, past few years, add a new syntax to support immutable variables. They're not quite as immutable as Haskell. But they're still basically immutable because it's so error prone to just change the values of our variables all the time. So now let's talk about how to make the variables in Haskell. Remember, variables are just a name for something or a box that we keep things in. As this is our second video in the intro to programming with Haskell, I'm going to walk you through making the project again. So we cd into our source directory or wherever you're keeping your projects, and we just do stack new, I'm going to call it hello world variable. And stack told us some things, it finished. So we're going to hello world variable. And I always do stack run in a new project to get the initial compilation out of the way. Sometimes it might need to build a new version of GCC because stack got upgraded or whatnot. Sometimes there's other library files that need to be recompiled. Also, I know that everything is working right now. I'm in a known good state. So anything I change is from a known good state. I can undo the change and it'll work again. So let's open up that file. Remember, app is a directory that holds main. So hello world variable /app/main.hs. If you're on Windows, it'll be a \. And if you're using a GUI file manager, you'll see the little folders. You probably recognize this. You will get to know this, this version of main more and more and more. This is the default main that Stack produces for us. We don't need that import statement. So I'm just going to write hello world, put Sterling hello world. This is our basic hello world program in Haskell. And I'm going to run that again. And we see it says hello world now. It did compile again. This is hello world now instead of some func. So we're in another known good state here. So we're back to hello world. Now we can make some changes. And the changes we're going to make are variables. So remember, variables hold things, variables name things. What's the syntax to make a new variable? In Haskell, there's a couple of different ways to make variables. There's more than a couple. I'm going to talk about the two we can use right now. There are a couple of other ways that we'll talk about later, but not for now. Now I'm just going to name my variable x for right now. Now we've made a variable with our let clause or let notation. We've made a new variable and we told the compiler what that variable is. Now I don't even know that it's possible not to tell the compiler what the variable is in Haskell when we create one. It's best practice to always do this anyway in any language. So let's run it. Now hopefully some of you will have noticed that there's a bug here. Our compiler is going to give us the bug. It says, hey, you defined X, but you didn't use it. What's going on? So that is true. We go back and we look, and it tells us which variable it points us at. The variable, or the line where we defined the variable that we didn't use. And in maintenance programming, it's very common to wind up with extra variables after you've refactored some code. That's fine. You may just want to delete them after that, depending on what you're doing, right? And our programs right now, that while we're learning, this is almost always going to be a real bug, not something that we can sort of ignore. You'll notice this is a warning, not an error. That means the compiler could still do its job. He's letting us know that he thinks he found a bug, though. And in this case, he did find a bug. And you see down here, it still ran because he could still do his job. He still ran and said, hello world. But he said, I think there's something wrong with this. And indeed there is. This is not the output we wanted. So we correct that by doing put Sterling x. So we've made our variable. And now we're going to use our variable or reference our variable. And that's how we do it. It's as easy as that. We just put hello world from x into a box, into a name. We've named it lowercase x. Case always matters. So we've named it lowercase x. And here we're just saying put Sterling whatever's in lowercase x. So we'll run that again. And indeed it worked. Hello from x, just as we would expect. Excuse me. So let's talk about the other way to do this. I'm an old C programmer, so I tend to, by nature, list my variables and their values up top in that let clause. This is the other way we can do it, and I see this most commonly and when I'm looking in Haskell libraries. I'll often see where clauses, not let clauses. So we definitely need to learn this one as well. So this time we've called x hello. We've given x the value hello from the where clause, and that's a string. And indeed we get hello from the where clause. Now when I move stuff around like this, I will often rename things. And this is special, like you saw, I changed the string here, and that's especially important when we're doing things like this, to make sure that everything worked right, because sometimes it's possible, this happens to me several times a week, I forget to save, possibly several times a day when I'm programming a lot, I forget to save the file, and if the expected output didn't change, then I get this false sense of security. I think everything's working because it used to work, but my change broke something, and I don't see that because the file wasn't saved. So I always make sure that I try to change a little bit of something in the expected output after the change I made, especially when it's something where it might be confused, like just a string value or something. And you can change it right back later. So this is the other way to make the variable, where we've said, hey, name this string X. Hey, put this string in X. And it's the same thing. We use X and put strlen. The compiler knows that this is a function that takes a string and puts that string onto the console, onto the terminal with the new line. And X is a variable that holds a string. Excuse me. So everything works out just fine. And that's all there is to defining a variable in Haskell. It's very light on the syntax. We don't have to do much. So we could practice with just that, but it's a little more entertaining to do some other things. So I'm going to go back to the let clause. Now here I've named the variable X initially because we had there was no real meaningful name for our simple program here. I'm going to change it to message though, because we're going to change some other things and we're going to add new variables. So we need a few more names. And when you use short variable names like that, it's best that the function is very short. If the function is long, then those variable names are can get really confusing really fast. And it says hello from the where clause. So let's just make sure I saved it properly, and it did. So we glue strings together with this operator right here. There's another operator I'm going to show you, but you don't have to remember it. This glues, it's list concatenation. It will glue two lists together, and lists are strings. So we could glue two strings together with this, or I'm sorry, strings are lists. So we could glue two strings together with this just as well. But this is a more general operator that will glue many things together, not just lists, and strings are lists. And we haven't talked about lists yet. We'll talk about them later. So for right now, we're just going to say we're going to glue hello to world. And there's a bug here. Now this is a bug the compiler can't find for us. So we have to learn to look for it ourselves. I'll run this. And now we see, it might be hard to see if we're too used to just glancing at this, but there's no white space here. So we have to train our eyes a little bit to see that there's no white space here. And up here, it's because we didn't add the white space. Now there are lots of ways to do this. Fastest and easiest is probably just to put the white space at the end of hello. So now it's hello, white space, and then we're going to glue world onto that. So now we see it's fixed. Now there's a couple of other ways to do this. The absolute best way for anything longer than a couple of strings or a couple of short strings is to use a library function that we're going to talk about later. That's probably the best overall, but for right now we're not learning that. We need to learn how to do it the more manual way, where we just put like the hello space concatenated with world or glued to world. The other thing we could do, of course, we can move the white space over in front of the world, because it doesn't matter which of these strings it goes in, it just needs to get out onto the console. And indeed we see hello space world is right there. So we've glued the string hello with no spaces to the string space world, and of course space shows up. And this is really common when you see people like just glomming things together, and you might see a bunch of strings with the space at the end. And by the time it gets to be more than a few, we need to start thinking about a different way to do it. This is probably the most meaningful way. We can glue more than two strings together. In fact, we're always just gluing two strings together, but we glue these two together first, and then we take that string and glue it to this one. So we can glue as many together as we want. And we put the white space in the middle. So this is probably the most natural way to use these operators to sort of glue strings together, to append strings, because we just see the white space shows up where we think it should show up. I don't see this as often in the wild because, as I said, there's a library function to do this for us. There's lots of other ways to do this sort of thing, but for short, quick and dirty things, this is not quick and dirty anymore. This looks nicer, but it's no longer very quick and dirty. So I generally see the white space on one of the other words. But I'm going to run this just so you can see it. Indeed, it worked just fine. Now I'm going to show you something real fast. And this may be a little bit confusing, but I think some clever and industrious people are going to be doing this soon on their own. So I want to talk about it real fast. You could just put the string here. The problem is you're going to get an error. And the reason you get an error is Putzerlin order of assignment for order of operations means that hello gets passed into Putzerlin and not the whole string. So in general, we evaluate from left to right. And so Putzerlin tries to put hello on there, and then we try to concatenate Putzerlin returns. This will make more sense when we talk about functions. It returns an IO of type unit, and then we try to glue stuff together. And if this is just making no sense, it's fine. You can just ignore it. I'm just going to run this so people see the error message. I couldn't do this, and we haven't learned enough to really interpret this error message. When you see that, go look at the line number and see what's going on. In this case, there's too much stuff after Putzerlin. And we can correct that by just doing this. So if you want to glom more stuff together on the Putzerlin line, that is great, 100% okay. You just need to use those parents. You see it works fine with the parentheses. Now, don't worry about that too much. If really using variables here is probably the best way to do that. So go ahead and just use the variables to your heart's content. And if that made no sense, that's fine. Just ignore it. Just remember, we put Putzerlin our message, and we can assign message our things, and we can glue strings together and put the result into a variable. So the variable will glue all the strings together for us, and it works just fine. So that's how we glue our strings together. Now, suggestions for practice. For some of these videos, I'm going to go ahead and work through these with you, and I hope that you take the time to do it on your own after the video. But define a variable in terms of a different variable is probably a bunch of words that make sense individually, but is confusing because we haven't really talked about all of that stuff yet. We just talked about variables, and this defines a variable, but what about in terms of another variable? That just means use another variable in the definition, that's all. So we'll make a hello, and we'll make a world. And now we've got a variable named hello and a variable named world. And those are defined as these string literals. And now we can use those string literals in the definition of the variable message. So message is now defined using these other variables in terms of these other variables. And we still have the white space between. And I'll run this. And we see it shows up just fine. But since it's the same output we saw last time, let's just make sure we can just put some extra cruft on the end. And indeed, the extra y's showed up. So it did change the way I think it would change, which is the next one for practice. Just change the values of the variables and see what happens. Try change the value of a variable and see what happens is the next one. That one we've been doing a lot, and you saw I just did it there. And we can run it again and see that it went back to normal. So for what you do on your own, what I would do if I was learning a new language is I would maybe make some more variables. I'd maybe get rid of some variables. I maybe play around with variable names. There's special ways to name them. They have to start with a letter. There's no spaces in it. And in Haskell, if you need an extra little bit, you'd put like a capital usually. So like hello-stir, world-stir, that sort of thing. So you can play around with that and get used to how that works. So that when we get to the next video, which is going to be about functions, we can talk about function-sake arguments, which are a lot like variables, just in a different sort of context. So that is that. I think we're done for the video. So we are. We talked about different ways to think about variables, what they mean, what they are. It's not a math variable. It's much more concrete than a math variable. They're like a container we can put things in. It's like a name we can give to things. Sometimes we say we bind a name to an expression. So that's all the variables are. We just refer to something else. We talked about how we can't change them, but that doesn't matter much because a compiler won't let us. It's only for those of us who have learned other languages first and are coming into Haskell later that this can be a little bit of a tripping point. For those of us learning it for the first time, we're never going to run into it, so it'll be just fine. We talked about how to make the variables using the let clause and the where clause. Both are great. Use the one you prefer. I generally see where clause when I'm reading other people's code. I generally use the let clause in my own for no particular reason, just personal preference. We talked about how to glue strings together with the less than sign, greater than sign, that sort of pointy append operation. And then we talked about how we actually went through, we looked about what we can do to practice on our own and how we might do that. And I walked through that with you. And that is it for this video. As always, questions and comments are welcome. Thank you for watching. Please click like and subscribe, and I hope you have a wonderful day.